What up? It's your boy Dave, aka Demolition Dave, aka David the Goliath, aka Data Science Dave, and today we are here to talk about this mega sick differential privacy tool called OpenDP. And that probably raises 4 questions. 1, what is privacy? 2, what is differential privacy? 3, what is OpenDP? And 4, who is Demolition Dave? Well, I'm glad you asked because we are about to answer all of those questions and more in the following video tutorial presentation. So let's strap in and get going. So the first thing we got to ask ourselves is, why are we here today? And well, you're probably a programmer or a data scientist or somebody who works with programming or data or code or science or deployment or operations. And in your career, you might actually be asked, hey, have you ever heard of differential privacy? And that's a great question because there's been a steady adoption of DP tools throughout industry with Google, Microsoft, Apple, even the government with like the US Census Bureau. And so most software tech leads, understandably, don't have a lot of differential privacy experience. So the goal here today, well, we're going to use some tools, we're going to generate some private data, and we might even just break some stuff if we're lucky, which defines our goals for today. Well, learn what privacy is, learn what differential privacy is, and learn how we can use differential privacy in data pipelines. First off, we're going to define privacy. Now, according to this old dude, privacy is the right to be let alone. And it might sound odd as a tech person that we're jumping like way back to almost when like electricity was invented, kind of, sort of, but the way we apply differential privacy is informed by our definition of privacy. Whenever you're looking to use DP to solve a problem, you have to know what you consider to be private. And that can be anything from COVID infection status to instances of defaulting on loans or race, gender, sex, ethnicity, any sort of information we might consider to be sensitive. That's the bit that we want to protect. And this idea of differential privacy is essentially that if you have 2 neighboring data sets, let's say for our example, we have 10 people in a COVID infection status data set. If we swap out one person, say like only one record, that's a neighboring data set. The sets differ by only one data entry. The released aggregate statistic using differential privacy is going to be the same. For example, the percentage of individuals with COVID, or say like the median or the range. Those are aggregate statistics. And the cool part about DP is that you can actually prove this with math, but we're not going to do that here because that's a little out of scope. So where do we go next? Well, the cool thing is that we can apply DP to almost anything, but specifically here, we're going to apply it to movie ratings. So let's take a look. So let's say we have our user data, in this case, movie ratings. With DP, there's a handful of different ways we can look at this problem, but the 2 simplest involve a local model and a central model. It probably wasn't clear, so I just want to wrap back. The magic part about DP is it's basically just noise. We're adding noise to the data. We're like smudging it, fuzzing it kind of. If you zoom out, it looks kind of the same, but if you zoom in close, you can tell that we did something to the data. And this noise can come in a bunch of different shapes and colors and sizes. You can have Gaussian noise, Laplacian noise. You can apply noise using the exponential mechanism or another algorithm like randomized response. And we can choose to do this locally or globally. Locally on a user's device, or globally with the entire data set. We can apply noise locally on the device before we send the information back to the central server with an algorithm like randomized response, or globally once we've aggregated all of our data using, say, like Laplacian noise or Gaussian noise. And there are some key mathematical differences in privacy versus utility trade-off here involving epsilon, or the privacy parameter. But again, the math is a bit out of scope, and we're just going to focus on the global model because that's how OpenDP operates. Jumping into our code base, let's take a look at our data. We've got movie ratings, users, and movies, and we're going to be focusing on the movie ratings column. So walking through our code, we're going to load this data into a data frame using pandas, and then we're going to use OpenDP to import the smart noise synth, or a synthesizer for private data synthesis. And there are several different data synthesis algorithms that OpenDP currently offers, of which a few we're going to try out here. And we're going to load these synthesizers into objects, and then we're going to pass our data file to that object after we do a little bit of pre-processing to drop the columns so that we're only passing the movie ratings to the synthesizer. And after we pass that movie rating to the synthesizer, we are going to generate the data, and from that, just for the sake of this toy example, we're going to calculate the average movie rating across all movie ratings. So now we're going to run the script, use 3 different data synthesis algorithms, and these new data sets are output into separate files that we'll check out in just a moment. And each algorithm is going to work with the data in a slightly different way, and each will have a different set of factors that we need to account for when considering our privacy versus utility trade-off. And this is outside the scope of the video, but the idea here being that there's probably going to be a best choice algorithm for the kind of data that you're working with. And looking at the output here, we can see that the average ratings across each new synthetic data set, like we talked about previously, this is like zooming out. We can see that there's a pretty similar average movie rating across each statistic, but then if we check out all of the individual movie ratings files, we can see how they each differ across the individual movie rating entries. Zooming in and looking up close, we can see that there's a bit of a difference here between the individual records. Okay, cool, so awesome, you say, Mr. Data Science Dave. We've got some synthetic data, but what do we actually do with it now? Well, that's another great question, and I'm glad you asked. You can try training your machine learning models with the synthetic data and comparing the accuracy, or you could try doing other fancy pants things like adding one record to another record. But wait, beware, just because we have private synthetic data and we can mathematically prove that this is private, that doesn't mean it's safe out in the wild. We can't just release it and let it run scot-free. There's still a privacy budget. And if we expend that privacy budget by running a number of queries on the data set, an adversary may actually be able to carry out a reconstruction attack. This is really important to consider when releasing data to the wild. If you're planning to release it to the wild, differentially private synthetic data is not going to be your solution. If you're planning to allow your data scientists to access the data remotely as an organization internally, while maintaining tabs on the number of queries that they run or the different kinds of operations they carry out or the amounts of data that they ingest, you're going to be in business. As a tool, OpenDP is just fantastic. They have amazing documentation. The synthetic data generation works at the global level, not the local level, which is somewhat of a limitation, but on the whole, OpenDP is just fantastic. They're going to be around for a while, so I would definitely recommend checking them out if you're a data scientist or a machine learning person or like anybody who works with data. You're going to love them. They've got a lot of great information on their website, and we use the Smart Noise Synth today. As a privacy professional, I got to say I am just the biggest fan of OpenDP. Just a quick recap, we covered what privacy is, what differential privacy is, and how we can start to look at using tools like OpenDP to generate private synthetic data. Maybe in future videos, we'll learn a little bit more about Demolition Dave. But until next time.